Hi students, this is Mr. Yang. In this lesson, I'm going to talk about the first two questions from the project that we did today. If you didn't fully understand them, please watch it over again to make sure you understand it. So, number one. At her party, Sarah is serving pepper jack cheese and cheddar cheese. The cost of pepper jack is $4 per pound, and the cost for cheddar is $2 per pound. She wants to have at least 2 pounds of each. Sarah wants to spend at most $20 on cheese. Graph the system inequalities and find the most amount of cheese Sarah could buy. Let X be pounds of pepper jack and cheese, and let Y be the pounds of cheddar cheese. Step 1, graph each axis, label each axis. So here's our graph. We actually have the labels. This is our X, so that's the pepper jack, and that's our Y, that's the cheddar. Step 2, write an inequality for the number of pounds of pepper jack cheese bought, emphasizing on number of pounds of pepper jack. So if you go back and read the question again, it says the cost of pepper jack is $4, so clearly that's not what this part is asking for. It's not asking for the cost, it's asking for information about how many pounds. And since we're using X to represent pounds of pepper jack, we're using Y to represent pounds of cheddar, that means we know X is going to be involved for this one. The piece of information is actually right here. She wants to have at least 2 pounds of each. At least 2 pounds of each, so that's going to be X is greater or equal to 2. That also tells us about step 3, write an inequality for the number of pounds of cheddar cheese, which is Y is greater or equal to 2. Next, step 4. Write an inequality for the cost of both cheese. So these two are from the first two steps, the previous two steps. Now, since this time we are actually talking about the cost, pepper jack is $4 per pound, and cheddar is $2 per pound. For pepper jack, the cost is going to be 4 times however many pounds, which is X. And for cheddar, it's going to be 2 times whatever, however many pounds of cheddar is, which is Y. That's why we add them together. And the question said at most. That's why it's going to be less than or equal to 20. Next, we're going to graph. I'm going to graph the two straight lines first. This is X greater or equal to 2. This is Y is greater or equal to 2. So it's going to be right here for the X, and it's going to be right here for the Y. Again, X is going to cross the X-axis, so Y is going to cross the Y-axis. And now let's graph the last one. We're going to need to solve for Y first. So 2Y is less than or equal to negative 4X plus 20. Y is less than or equal to negative 2X plus 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 2 over 1, because that's our slope. Down 2 over 1, down 2 over 1, and down 2 over 1, down 2 over 1. There's our line. Now we need to shade. For the green ones, well, they're all greater than, so that's going to be pointing to the right. This is pointing up. For the blue one, it is less than or equal to, so that's going to be pointing down. So we are going to shade this section. Next, we are going to find the coordinates, which are right here. And this part is what we have learned yesterday. This is 2, 2, and that is 4, 2, that is 2, 6. Check vertices to find the most amount of cheese Sarah could buy. Most amount of cheese. So this is not asking for the cost. It is asking for the pounds. Yesterday we have learned something called objective function, and that is the function we're trying to find a maximum or minimum for. In this question, we don't have an objective function. However, you can come up with the objective function. It's asking for the amount of cheese Sarah could buy. Sarah is just buying pepper jack, and Sarah is also buying cheddar. Cheddar is Y, and pepper jack is X. So the total amount of cheese Sarah is trying to buy is going to be adding them together, X plus Y. And we're just going to call it C of XY since it is, a function about cheese. So we're going to call it C. Now we're going to use the points to find the maximum. First, 2, 2. That's going to be 2 plus 2, which is a 4. Next, 4, 2. So add them together. 4 plus 2, that's going to be a 6. and then 2, 6, add them together, 2 plus 6, that's going to be 8. And as you can see, this actually is the greatest, so maximum equals 8 at 2, 6. That's question 1 on the project.